Math 3 Lesson Summary Video, Water Wheels and the Unit Circle. This lesson is a practice understanding task, which takes concepts you have been working on and applies them to new situations. The purpose of this lesson is to define sine and cosine as points on the unit circle for angles measured in radians. Water wheels were used to power flour mills before electricity was available to run the machinery. The water wheel turned as a stream of water pushed against the paddles of the wheel. Consequently, unlike Ferris wheels that have their centers above the ground, the center of the water wheel might be placed at ground level, so the lower half of the wheel would be immersed in the stream. The following diagrams show potential designs for a water wheel. Each of the 12 spokes of the water wheel will measure 1 meter. In addition to the spokes, the designer wants to add braces to provide additional strength. Two potential placements for the braces are shown in the following diagrams. The braces and the spoke to which they are attached form a right angle. Find the measures of angle BAC and angle ABC in each diagram. Find the exact lengths of segment AB, segment AC, and segment BC, not just decimal approximations. Explain how you found these lengths exactly. And label the exact coordinate points of B in each diagram. So when we look at this situation, we know we have 12 spokes. And if you think back to one of the previous lessons, we already have discussed that if there are 12 spokes, this would be 2 pi divided by 12, which would be pi over 6 for each spoke. So if this is 0, then this would be pi over 6 radians for its angle measure. We also know 360 divided by 12 is 30 degrees. So this would be a 30-degree angle. So now we have our exact angle measures for this one. We can carry that over to this second one because this second one is going to the second point. So if we're counting by 1/6, 1/6, 2/6. 2/6 reduces to pi over 3. So that would be its radian measure. We also know if this is 30 degrees and this is 30 degrees, then the whole thing would be 60 degrees. So we've found our angles for these two triangles. Now we want to find exact lengths. Now they told us that the wheel is going to have a radius of 1 meter. So this side, we already have the exact measurement for. That's going to be 1 meter. So AB is 1 meter in both pictures. As we look at the triangle, it is a 30, 60, 90 triangle. In fact, both of them are 30, 60, 90 triangles. They've just been turned a different way. If this hypotenuse is 1, then the short side, because of our pattern we reviewed the other day, has to be half of that. So here is the hypotenuse of 1, so the shorter leg is going to have to be half of that. So it's going to be 1/2. We also learned that for the longer leg, you just multiply that by the square root of 3. So 1/2 of the square root of 3 is the square root of 3 over 2. So we have found the lengths of BC and AC in both triangles, and now we can write the coordinate points. We now know that this one is going to have an x coordinate of square root of 3 over 2, and this one's going to have a y coordinate of 1/2, whereas this one, it's flipped. The x coordinate is 1/2, and the y coordinate is the square root of 3 over 2. Based on your work above, label the exact values of the x and y coordinate for each point on the following schematic drawing of the water wheel. Remember that the center of the wheel is at ground level, so points below the center of the wheel should be labeled with negative values. As in the Ferris wheel models, label points to the left of the center with negative coordinates also. So if we think about the items that we just labeled, we said this first point was the square root of 3 over 2, 1/2, and this point was 1/2 square root of 3 over 2. We know that the radius of this circle is just 1, so this will be 1, 0. This one would be 0, 1. They wanted things on the left of the center to be negative, so this would be negative 1, 0. And things below the center to be negative, so this would be 0, negative 1. We also know that we have symmetry all the way around. These two will line up, so this is going to be negative 1/2 square root of 3 over 2. And this will be negative square root of 3 over 2, 1/2, because it matches up with that one. Everything down here will have to be negative, negative. So this is going to match up with that point. So it's going to be negative square root of 3 over 2 and negative 1/2, because now it's going down. This one will match up with that point. So it's going to be negative 1/2, negative square root of 3 over 2. When we come over here, these two will match up, but now we're below the center. So it's going to be square root of 3 over 2, negative 1/2. And this one will be 1/2, negative square root of 3 over 2. Notice we had to do no arithmetic, no calculations. We're using the symmetry to help us find all of these points. It would also be helpful to know what the angles are that go with them. And we know that we're counting by sixths, so this would be pi over 6. And this is 2 pi over 6, or pi over 3. 3 pi over 6, so that reduces to pi over 2. 4 pi over 6, which would be 2/3. 5 pi over 6. And then 6 pi over 6, which is just pi. 7 pi over 6. 8 pi over 6. That's going to reduce to 4/3 pi. 9 pi over 6. That'll be 3/2 pi. 10 pi over 6, which would be 5/3. And 11 pi over 6. And we end up at 12 pi over 6, which is 2 pi, which we knew a full circuit around a circle would get us to 2 pi. And then if we wanted degrees, degrees are also useful. We're counting by 30 degrees. So we would have 30 degrees, 60 degrees, 90 degrees, 120 degrees, 150 degrees, 180 degrees. Notice we're just counting by 30. 30 more than that would be 210 degrees, 240 degrees, 270 degrees, 300 degrees, 330 degrees, and then we end up back at 360 degrees where we started. So when you're filling out twelfths, things to remember, you're counting by 30s. You're not memorizing all of these numbers. There's no point to that. But you're memorizing that you're moving 30 degrees every time. And so I can count to figure out what another angle is. If I need it in radians, I'm counting by 1/6 of pi. 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, 11/6, 12/6. You can always just count the unreduced fractions first and then reduce the fractions afterwards, but we're just counting by sixths. And if we found these 2 points, we basically used these 2 points to find every single other point on the circle. And again, yesterday we learned that why we do that is so that we can find sine and cosine. So if I want to find sine of pi over 6, here's the angle, pi over 6. We know that the x is cosine and the y is sine. So the sine of pi over 6 must be equal to 1/2. The sine of 5 pi over 6. So I find the angle, 5 pi over 6. I know cosine is the x value and sine is the y value. So the sine of 5 pi over 6 must be 1/2. Cosine of 7 pi over 6. So 7 pi over 6 is this angle. We know cosine is the x value and sine is the y value. So cosine is equal to negative square root of 3 over 2. I found all of these without having to pick up a single calculator. And I got an exact answer, not a decimal approximation. One of the ideas we're trying to develop is the fact that the unit circle is your calculator. You don't want to remember or memorize every sine and cosine for every angle of the circle. It's unrealistic and very impractical. But if we know how the unit circle is made and how the unit circle works, we just have to remember a few facts to help us to build the entire circle. And then we can find sine and cosine for anything. Here's a plan for an alternative water wheel with only 8 spokes. Label the exact values of the x and y coordinates for each point on the following schematic drawing of the water wheel. Hint: you might want to begin this work by finding the length of the brace shown in the diagram. If you recall from our lesson the other day, if we have 8 spokes, then we're dealing with 360 divided by 8, which we determined was 45 degrees. So if this is 45 degrees, each one of these will be 45 degrees more. So that would make this 90, 135, 180, 225, 270, 315, and 360. We also know radians-wise that we're counting by 2 pi divided by 8, which would be pi over 4. So this would be 1/4. This would be 2/4, which reduces to 1/2. This would be 3/4. This would be 4/4, which is just pi. 5/4. 6/4, which is 3/2. 7/4. And 8/4, which is just 2 pi. So that will give us all of our angle and radian measures for this circle. We also know that we have a special right triangle. It's a 45-45, 90 triangle. And it has a radius of 1. We discussed the other day that to find the 2 equal sides of the hypotenuse, we have to divide it by the square root of 2. But dividing by the square root of 2 left us with a non-rationalized denominator. So we're going to multiply by the square root of 2 over 2. And 1 times the square root of 2 over 2 is just the square root of 2 over 2. So that gives us our values for this side of the triangle and this side of the triangle, which gives us our coordinate point. Square root of 2 over 2, square root of 2 over 2. We already knew this point was 1, 0. This point was 0, 1. This point was negative 1, 0. And this point was 0, negative 1. And now we can use this point along with our symmetry to help us find the others. This one would be negative square root of 2 over 2, square root of 2 over 2. They would both be negative down here. Negative square root of 2 over 2, negative square root of 2 over 2. And the first one would be positive, and the second one would be negative for this one. So for this spoke, just knowing it's 8 equal pieces, we're able to find all of the degree measures, all of the radian measures, and all of the coordinate points for these angles. Because we have a radius of 1, we know that that means that the x value is the cosine and the y value is the sine. So we can answer these questions. What is the sine of pi over 4? Well, where is pi over 4? Pi over 4 is right here. This is its cosine and this is its sine. So its sine is the square root of 2 over 2. Find the sine of 5 pi over 4. So I need to find 5 pi over 4. Here's 5 pi over 4. This is its cosine. This is its sine. So its sine is negative square root of 2 over 2. Cosine of 3 pi over 4. Here's 3 pi over 4. Cosine and sine. So its cosine is going to be negative square root of 2 over 2.